Hello everyone, please let me know in chat if I'm audible to you or not. Okay, so I think I'm audible. So as you can see the title over here, in today's class we will be talking about B and B plus trees, right? So first of all, you must go and visit the Geeksforgeeks official website in order to get the details of this course of GATE CSE 2023 batch for 12-month course, right? You can just go and check the site for all the details of this course. Now in today's class we'll be talking about B and B plus trees, examples and assignments as well. Yeah, now you must all know that why do we use B and B plus trees, right? B or B plus trees. So we know about multi-level indexing, right? So suppose one index file, suppose this is my index and this index cannot be fitted in single block. So it can be the case where I have to use multiple blocks in order to store the index itself, right? So I am making the indexes like this, right? This is not exactly how it looks, but yeah, partially you can say. Now suppose this is the index, right? And here we have been given a data pointer which will, or you can say a record pointer, which will point in the record itself, right? So where this record is in the, in the disk or in the table like this, right? So this all pointers are for that purpose over here. But this multi-level indexing can be done in two ways, by using B trees or B plus trees. First we will be talking about B trees and then I'm going to talk about B plus trees. What are the characteristics of B trees? B trees is known as self-balancing tree, right? So if you are inserting any element or if you are deleting an element, it will be in sorted order by self, right? Its definition is like that the tree will always be sorted, and even if you are deleting anything, it will balance the height itself. In B tree, a node can have more than 2 children, right? So we will be drawing a tree like this. So here you can say this is the node. Now this is how you can draw the node. Here this is the block pointer, right, in B trees, as well as the record pointer will be there also, right? So here if it is D is there, then A, B, E, F, like this, right? Here if it is H, then M, N like this. This is kind of a B tree. So where this D is located in the disk, so this is also given the record pointer over here and the block for which we can find. Like, see, why I cannot use binary tree over here, search, or why I cannot use simple indexing, sequential indexing over here. सिक्वेंशियल इंडेक्सिंग का ड्रॉबैक ये था कि उसमें अगर मैं सिक्वेंशियली सर्च कर रही हूँ तो ओवरहेड बढ़ जाता है. यहाँ पे आई कैन एलिमिनेट दैट ओवरहेड बाय सर्चिंग. अभी इसकी डेफिनेशन में क्या होता है कि द वैल्यूज लेसर देन दिस विल बी ऑन लेफ्ट साइड एंड वैल्यूज ग्रेटर देन दिस विल बी ऑन राइट साइड, लाइक दिस. So I can search the element efficiently. Now here D is here only. D is the data, or like you can say it's a key, but it is not inside this leaf node, right? It is not inside the leaf node. So where this D is located in the data file or file system, so for that we have been using this pointer over here. So the structure of internal node or leaf node, structure of leaf node is different in B tree and B plus tree, right? I'll be talking about it and I'm going to cover the examples as well. So it can have more than 2 children. Children is like this. If this I'm pointing, right, then it is known as children. Minimum, this value can be there. So minimum 2 children or more than 2 children can be there also. The height of B tree, like you know about the height of binary tree, right? Binary tree की height होती है log n, where n is the total number of nodes. यहाँ पे 2 इसलिए क्योंकि वो बाइनरी ट्री है. अगर मैं एनरी ट्री ड्रॉ करती हूँ और एमरी ट्री ड्रॉ करती हूँ तो आई कैन राइट like this height, right? So same way we are using height of B tree over here. The height is adjusted automatically at each update. In the B tree, data is sorted in specific order with the lowest value on the left and highest value on the right side. To insert the data or key in B tree is more complicated than a binary tree, right? There are some conditions that must be satisfied and must be held by B trees. All the leaf nodes of B tree must be at the same layer or level. Like it can be like this only. Not exactly. Just a second. Suppose this is first, this is second, right? And this is third. Then if it is divided further, then it will be like this only. It can suppose this is not having any children. This is not possible in B tree, right? Above the leaf node in B tree, there should be no empty subtrees. There should be no empty subtrees that I have already mentioned. In B tree, height should be as low as possible. So here I have given an example. Here you can see that this is the data. This is the data. It is not appeared in the leaf node. What is B plus tree? अभी B tree का disadvantage क्या था कि उसमें सर्चिंग के लिए मैं record pointer और data pointer जो है वो internal nodes में दे रही थी. Now in B plus tree, all nodes are present or all key values are present in the leaf node itself. It can be left biased or it can be right biased. Let me show you. If I am having 1, 2, 3, 4, 5 numbers and I want to insert into the B tree of order, say 2. What is order 2 over here? That means or say order 3. Order 3 means sorry for the inconvenience over here. Right, so here actually if I want to insert 1, 2, 3, 4 and 5 in the B tree of order say 3, that means the root node can have or all the node can have maximum 3 childrens like this. Right, now each internal node can have 3 childrens as well. Right, so this is how you can draw the node. Now what is happening? I am entering 1 then 2. Now for D order I can have maximum D minus 1 keys. So here for this node 1 and 2 can be inserted like this. Now if I am inserting 3, then the node is overflowing, so I have to split the node like this, and here I can draw like this. This is known as right biasing. Why right biasing? Because this data is appeared on right side of tree. If I am drawing something like this 1, 2, 3, this is overflow, then I am doing something like this 1 and 2 and over here 3. Then this is known as left biasing. Now number of splits in left bias and right bias may differ, so if ever they are asking you about the biasing, you must calculate how much maximum can be in left or right, and you have to choose maximum from them. Now when I am entering 5, it will be overflow over here, so it will be like say this 2, then 1, 2, here 3, 4, not 4 over here because it is splitting. So 4 will be above, here it will be 4 and 5. Now if I enter in 6, there is no split. So this is how you can insert an element into B trees. It eliminates the drawback B tree use for indexing by storing data pointers only at the leaf node. So in B plus tree data pointers will be there only at the leaf node. So leaf node के लिए क्या होगा कि अगर मेरी ब्लॉक साइज सर्टेन दी गई है ब्लॉक साइज, तो एक ब्लॉक में लीफ नोड के लिए क्या होगा, तो देखो उसमें इस तरह से है, लीफ नोड का स्ट्रक्चर उस तरह से है। तो एक ब्लॉक पॉइंटर है जो दूसरे नेक्स्ट ब्लॉक को पॉइंट कर रहा है और वैल्यू है एंड डेटा पॉइंटर है। तो अगर मेरा ऑर्डर है n, की साइज इज k, record pointer or data pointer is having size say r and block pointer is having size b, then you can write it like order n minus 1 k plus r plus block pointer size less than or equal to block size, like this. Okay, so this is how you can let me just adjust my photo a bit so that I hope you can see what I am doing with my PPT, but it is necessary so that the background is not cutting, right? This is okay. For this, this is okay. I think this is also okay. This, for this, I can do something like this. I think this is okay also. Okay, so we'll be starting with B plus trees only. So it eliminates the drawback of B tree used for indexing by storing data pointers only at the leaf nodes of the tree. The structure of leaf nodes of B plus tree is quite different from the structure of internal nodes of B trees. So I have already show you. तो B trees में क्या था, record pointer and block pointer दोनों थे यहाँ पे, पर यहाँ पे थे ये record pointer है, ये record pointer है, ये block pointer number of childs like this, और B tree में वो नहीं होगा। तो B tree में यहाँ पे सिर्फ block pointers होंगे, right? Record pointer हमें leaf nodes में ही मिलेंगे। Since data pointers are present only at the leaf node, the leaf node must necessarily store all the key values along with their corresponding data pointer to the disk file block. The leaf nodes therefore form a first level of index. Leaf node first level पे है, and the internal nodes forming the other levels of multi-level indexing. Right. Some of the key values of leaf node also appear in the internal nodes, so simply act as a medium to control the searching record. You can just read it out and know. This is the structure like this. Okay, तो ये डेटा फाइल है, एक्चुअल डेटा फाइल में 2 कहाँ पे है, वो रिकॉर्ड पॉइंटर हमें यहाँ पे दिखाएगा, और नेक्स्ट जो है पी ऑफ नेक्स्ट लाइक नेक्स्ट ब्लॉक का रिकॉर्ड हमें यहाँ से मिलेगा. नाउ यू कैन ट्राई टू सॉल्व दिस एग्जाम्पल. हियर द फिगर शोज बी प्लस ट्रीज. तो ये बी प्लस ट्री शो कर रहा है एक्चुअली, where only key values are indicated in the record. Each block can hold up to 3 records. तो एक ब्लॉक में 3 records ही रह सकते हैं. Record with the key value 34 is inserted into B plus tree. तो अगर हम 34 insert कर रहे हैं तो वो यहाँ पे insert होगा. तो it will be like 2, 8, 18, 32. Now see, it is right biased. So 32 and ये क्या हो जाएगा, 32, 34, 50 and 72 like this. फिर यहाँ पे आएगा 81, 106. I am not drawing the rest of those because it will be same actually. तो यहाँ पे क्या होगा, कि ये जो 50 है उसको हम निकालेंगे बाहर, तो यहां से हम स्प्लिट करेंगे ऐसे, और ये 50 यहाँ पे जाएगा तो ये बन जाएगा ऐसे, और यहाँ पे आ जाएगा राइट बायस 50 वाला, लाइक दिस। क्या था 50 एंड 72, एंड हियर दिस विल बी लाइक दिस। अभी ये यहाँ पे मैक्सिमम इंटरनल नोड में मैक्सिमम 2 ही रह सकते हैं, तो अगेन आई एम लिफ्टिंग दिस 50 लाइक दिस, तो ये ऊपर जाएगा 120 50 250 लाइक दिस, एंड यहाँ पे हो जाएगा 32, यहाँ पे हो जाएगा 81, यहाँ पे जो है वो एज इट इज रहेगा 120 वाला ये वाला, और यहाँ पे जो है वो भी एज इट इज रहेगा, राइट। नाउ 32 वाले में कौन आएगा 2 8 18, और यहाँ पे आएगा ये वाला 32 एंड 34, यहाँ पे ये एक रेफरेंस होगा। फिर ये आया यहाँ पे 81, राइट। तो 32 एंड 34 यहाँ पे आ गया। अभी यहाँ पे 81 के पहले कौन आएगा, तो यहाँ पे जो है वो कौन सा है 50 एंड 72 लाइक दिस, एंड यहाँ पे 81 लाइक दिस। So you can continue the process like this. I have shown you the updated part. You can draw the tree like this by splitting all the nodes. यहाँ पे जो है वो सेम रहेगा 150 205 एंड 520, यहाँ पे जो है डिफरेंट रहेगा। फिर यहाँ पे जो स्प्लिटिंग होगा और 120 यहाँ पे आ जाएगा, राइट, लाइक दिस। एंड ये दोनों जो नोड्स है तो ये इस तरह से कुछ बनेगा, 120 यहाँ पे, फिर 50 एंड 250 का होगा, फिर से ये लेयर्स हो गए, एंड फिर लास्ट लेयर। तो 3 हाइट का इस तरह से हमें ट्री मिलेगा। लेट मी नो इन चैट इफ यू आर हैविंग डाउट रिगार्डिंग दिस, राइट। Now the next question, which of the following is correct? B tree are storing data on disk and B plus tree are storing in main memory. So this is not correct. Both of them are storing data in disk only. Range queries are faster in B plus tree. So this is actually correct because range query क्या कहता है हमें कि लाइक से सैलरी ग्रेटर देन 50,000 एंड लेस देन 1 लाख। तो अगर मैं लीफ नोड में एक पर्टिकुलर नोड पे पहुंच जाती हूँ तो नेक्स्ट पॉइंटर से मुझे बाकी के सारी रेंज अप टू 1 लाख यहीं पे मिल जाएगी। दिस इज नॉट पॉसिबल इन बी ट्रीज, राइट। सो बी प्लस ट्रीज में रेंज क्वेरीज ज्यादा जल्दी से एग्जीक्यूट होती है। बी ट्रीज आर फॉर प्राइमरी इंडेक्सेस, बी प्लस ट्रीज आर फॉर सेकेंडरी इंडेक्सेस। दिस इज ऑल्सो इनकरेक्ट। द हाइट of B plus tree is independent of number of records. It is also incorrect. It depends on the number of record, right? More the records, more the height. The next question is the order of internal node in B plus trees. Internal node की बात की गई है तो internal node में क्या होगा, number of n-1, n अगर उसका order है तो n-1 keys होगा, and n child pointers और block pointers हो गए। They should be accommodated in 1 block size, right? So ये internal node का structure है in B trees, B plus trees, right? तो n-1 यहाँ पे क्या ये क्या है एक्चुअली 512 की सर्च की है 14 बाइट्स, तो यहाँ पे n-1 होगा 14, और चाइल्ड पॉइंटर है 6 बाइट्स, तो यहाँ पे 6 into n, राइट। तो दिस विल बी 14n minus 14 plus 6n लेस देन और इक्वल टू 512। तो यहाँ पे हो जाएगा 20n minus 14 लेस देन और इक्वल टू 512। तो ये हो जाएगा 20n लेस देन और इक्वल टू 512 plus 14, that is actually 6 and 2 and 526 divided by 20. If you just draw this, you will be get the answer of, say, what will the answer over here? I hope I'm not missing anything. So what will be the answer over here? Actually the answer will be 2, 6 and 3, 23.6. So n should be less than or equal to 23.6. So you can say here is the answer. A B tree is used as an index for a large database table which already have four labels including the root node. If a new key is inserted in this index, then the maximum number of nodes that could be newly created or splitted, right? तो ऑलरेडी लेवल है वो 4 का है कुछ इस तरह से, और अगर मैं इस तरह से कुछ है, अगर मैं एक चीज इंसर्ट कर रही हूँ तो मैक्सिमम नंबर ऑफ स्प्लिट कितने पॉसिबल है? तो आप ही देखो कि हर लेवल पर अगर कोई स्प्लिट हो रहा है, अगर मैं यहाँ पे कुछ इंसर्ट कर रही हूँ, ये फुल हो गया तो ये स्प्लिट होगा, उसके बाद वो यहाँ पे आएगा, ये भी स्प्लिट होगा, ये भी यहाँ पे आएगा, वो ये भी स्प्लिट होगा, ये भी यहाँ पे आएगा, ये भी स्प्लिट होगा, तो ये नया बनेगा। तो नए कितने बने? 1 2 3 4 एंड 5. So 5 is the answer. This one is the easy one. This was asked in NET exam as well. Now B plus trees. So this is the assignment questions. Actually you have to try it by yourself. So this is assignment question, this one is also assignment question, this one is assignment question, and this is also, right? So you can just pause the video, try to solve the questions by yourself, and just acknowledge your knowledge, right? These are all standard questions that can be asked from B and B plus trees. If you are having any doubt, you can just let me know in chat, and sorry for the inconvenience of the curtain. Okay, so this is all about today, B trees and B plus trees. From next two lectures, we will be talking about model gate questions, right? Model gate questions. Right. So stay tuned with me from tomorrow and Monday as well at 9 p.m. and 8 p.m. respectively for the standard grid questions. Thank you so much.